Okay, so here's some basics on the unit circle. Okay, so we're not going to go into detail about how we come up with all these, but essentially what the unit circle is just like kind of a easy way for us to remember cosine, sine, and tangent values for some very popular angles. So what the unit circle gives us is a bunch of different angles. You can see we have those angles in degrees from 0 all the way up to 360. And then we have these common angles, 30, 45, 60, and so on. And then we also have those angles in radians. So 30 degrees and pi over 6, they're the same angle, just one's degrees, one's radians. And what the unit circle gives us is the cosine and the sine value for whatever that angle is. So for example, if I wanted to find the cosine of pi over 6, I would just go right here and I would say the cosine of pi over 6 is going to be the square root of 3 over 2. If I wanted to find the sine of pi over 3, I would go up here, and it looks like it's also the square root of 3 over 2, because it goes cosine and then sine. It's always going to work that way, cosine and then sine. Okay, so you might be thinking, where's tangent? Okay, so tangent isn't directly given to us, but it can be found pretty easily. All we have to do to find tangent for any of these guys is do sine over cosine. And when I say that, you can actually ignore the denominator when you're doing that, because see how all of our denominators are 2 here? So those aren't going to come into play. So I'll show you a quick example. To find out the tangent of pi over 6, I would take 1 over the square root of 3. So I took the sine and I put it over the cosine. And this guy I would actually have to rationalize, and that means getting rid of the radical in the denominator. So I'd multiply the top and the bottom by the square root of 3. And I get something like that. So the tangent of pi over 6 is square root of 3 over 3. So you do have to do a little extra work to figure out tangent for each of these guys. Think about the tangent of pi over 4. That's square root of 2 over square root of 2. The tangent is just going to be 1. Okay. So another thing that isn't given explicitly is our reciprocal functions. But remember, all our reciprocal functions are the flipped versions of our original trig function. So for example, if we wanted to figure out the cosecant of pi over 3. Now remember, cosecant is the reciprocal of sine. So I would go to sine, which is square root of 3 over 2, and I would just flip it. And I could get the cosecant really easily. And I would flip it, it would give me 2 over the square root of 3, and I'd have to rationalize. And I think that gives you 2 square root of 3 over 3. And that works with all these guys in this angle. In this entire circle. And then on top of that, what we learned was that we can also use this in the opposite direction. For example, we can find an angle that goes with a certain cosine, sine, tangent value. So that's when we're doing those inverse stuff. So for example, if we wanted to find the inverse cosine of negative 1/2, that just really means where on our unit circle do we have an angle that has a cosine of negative 1/2. But the thing is, we learned the other day that there's going to be restrictions on the inverses. So cosine, secant, and cotangent, if we're trying to find the inverse of any of those guys, we know it has to lie between 0 and pi. The reason we have these restrictions is because our inverse functions look something like this, right? And they are not 1-to-1, which means when we do a vertical line test or a horizontal line test, we hit our graph more than once. Okay, so in order to avoid that, we only look at a snippet of this guy. And the snippet that we look at for cosine, secant, and cotangent is 0 to pi. And for sine, cosecant, and tangent, it's from negative pi over 2 to pi over 2. So back to this. When we are looking for an inverse value, for example, if I wanted to find, let's just say we're trying to find the inverse tangent of, let's say, root 3. Right? So first I have to look on my graph and figure out where is tangent equal to the square root of 3. Now, remember, to find tangent, I have to really quickly, and you'll get good at it, you'll do it in your head, is do sine over cosine. So sine over cosine here is square root of 3. So that's one spot where tangent is equal to square root of 3. But there's going to be another spot. So look around. Looks like here I have square root of 3 over negative 1. That's not going to do it. Over here, I'm going to have let's see, negative square root of 3 over negative 1. There we go. That's positive square root of 3 for our tangent. So our two angles where tangent is equal to the square root of 3 is pi over 3 and 4 pi over 3. But remember, we just talked about the restrictions. Tangent has to be between negative pi over 2 and pi over 2. That means it must lie in either our fourth quadrant or our first quadrant. So the one we're going to put for our answer would be pi over 3. Right? This 4 pi over 3 doesn't work because it's outside of those restrictions. Right? So if you still don't understand at this point, I would highly suggest looking up on YouTube, seeing if you can find any other videos, maybe somebody who explains it in a way that you understand a little bit better than what I'm doing. But if you have any more questions, please let me know.